In this video, we will be discussing the triangle inequality theorem. So what does the triangle inequality theorem say? Well, the triangle inequality theorem says that if I'm given a triangle, the sum of the lengths of two of the sides is always greater than the length of the third side. So here I've got triangle ABC, and I know that if I took AB and BC and added them together, I would have something that is longer than side AC. Similarly, if I took AB and AC and added them together, I'd have something longer than BC. And if I took AC and BC together, I'd add them together and have something longer than AB. And this is true in every single triangle. So here's a triangle ABC. I'm going to show you that this is always the case. So up here I have some calculations. I have the measure of I have the measure of side length AB plus the measure of side length BC. And then I've got measure of CA. Then I've got AB and CA being compared to BC. And then I've got CA plus BC, and I'm comparing that to AB. And what you should observe is that no matter what, adding these two together will always give you a number that is bigger than what is over here for the third side. So to show you that it's not just on the examples that I've put here, I'm going to kind of manipulate this and show you. If you notice, I'm moving this triangle around, and this number is always changing, but it's always bigger than this number over here. At no point can I ever make a triangle in which the sum of two sides is not bigger than the remaining side. Now, interestingly, if I take and I try and make the sum of the two sides equal, let's see what happens. So I'm moving side B around. So side AC is not changing. So let's focus on, let's move these down here. Let's focus on these two things. I'm going to try and make this, the sum of AB and BC, equal the sum of CA. So as I shrink these down, getting closer and closer and closer and closer and closer and closer, and what you should notice is that the only way for them to be equal is if this is a straight line and B, the point B, is on side AC. Otherwise, adding AB and BC together will always give me something bigger than AC. It doesn't matter which two sides I look at to do that. That's always the case. The sum of any two sides is greater than the third. All right, so that is the triangle inequality theorem. It's a very useful theorem, and we are going to use it in two ways. This says it can be used in several ways, which is true, but we're going to focus on two. One way is we can determine if three side lengths form a triangle. All right? In order for three numbers to be the side lengths of a triangle, they have to follow this pattern, that the sum of two of them is bigger than the third. And the other way we can do this is that if we're given two sides, we can figure out the range of possible side lengths for the third. So let's go ahead and do this. Example 1 says, can the following three lengths form a triangle? So if I have side lengths of 17, 13, and 4, can I make a triangle? Well, we know that if I take any two of these, they have to be greater than the third. So if I take, for example, 17 plus 13, well, I need that to be greater than 4. Well, 17 and 13 is 30. That's obviously greater than 4. So, okay, that works if I use 17 and 13. If I use 17 and 4, 17 plus 4, I need that to be greater than 13. Well, 17 plus 4 is 21. That's greater than 13, so okay, that works. And also, if I take 13 and 4, I need that to be greater than 17. But that's a problem. 17 is not, 13 plus 4 is 17, and that's not greater than 17. 17 equals 17. So I've got two side lengths here that if I add them together, they are not greater than the third. So the answer is no. These cannot form a triangle because if I add any two sides together, I do not get a number that is bigger than the third. Okay? So you can't just be like, oh, well, I see 2 here. These 2 add together, and they're bigger than that one. And these 2 add together, and they're bigger than that one. No, you have to try all 3 possible pairs. So that's all you have to do. Add them up, add 2 together, see if it's bigger than the third. Add 2 together, see if it's bigger than the third, and add the last 2 together and see if it's bigger than the third. If all of these inequalities were true, then the answer would be yes. But because one of them is false, the answer is no, they cannot form a triangle. All right, so let's move on to the other thing that we would use the triangle inequality theorem for. And that is that if I'm given 2 side lengths, okay, sides AB and BC, I want to find the range of possible side lengths for AC. Okay, so if I think about this, I know the following relationships have to exist. AB plus BC is greater than AC. I know BC plus AC is greater than AB. And I know that AB plus AC is greater than BC. Okay, this just comes from the triangle inequality theorem that any 2 sides added together have to be greater than the third. Well, I know 2 of these numbers. I know AB is 12. So whenever I see AB, I can put in 12. And I know BC is 4. So anywhere I see BC, I'm going to put in 4. Okay, and I don't know what AC is. And AC could be a lot of things. In fact, there are infinitely many different numbers that AC could be. All right, so what can I do here? Well, let's solve all of these inequalities. 12 plus 4 is 16, and that we know is greater than AC. So we know that 16 has to be bigger than AC. So AC can't be anything bigger than 16. It could be 15, it could be 2, but it can't be anything that is smaller than 16. Okay, let's see. We know AC has to be, if we subtract 4 on both sides, AC has to be bigger than 8. Okay, just by following our subtract 4, subtract 4. So AC can be 8.001, AC can be 9, AC can be like 3, or no, AC can't be 3. AC has to be bigger than 8. And over here, I get AC is greater than negative 8. Well, if AC is bigger than 8, then it has to be bigger than negative 8 too, doesn't it? So this one maybe doesn't matter so much if I know this one. Also, we can't really have negative side lengths, so this one also doesn't really make any sense. So really, it's these 2 that I need. And if I look at these 2, I know AC has got to be bigger than 8, and I know that AC has got to be less than 16. So how can I rewrite these so that they have the exact same sign? Well, one way I could do that is I could say, well, they do already have the same sign, but what if I said this? What if I said that 8 is less than AC? Okay, that's just this flipped. And then we also know that if I flip this, AC is less than 16. So then I could say, well, AC is less than 16. And there we go, I've got a range. I know that 8 is smaller than AC, and AC is smaller than 16. So AC can be any number in between 8 and 16. AC could be 9, it could be 13, it could be 15, it could be 14.2. Doesn't matter. If we pick any number in here, let's say we use 10. Well, if I use 10, 8 plus 10, well, I want that to be bigger than, I'm sorry, not 4, not 8. I know my other 2 sides are 12 and 4, so what if I say 4 plus 10? I want that to be bigger than 12. Well, it is. 14 is bigger than 12. If I say 12 plus 10, I want that to be bigger than 4. Well, that's 22. That's bigger than 4. And 12 plus 4, I want that to be bigger than 10. Well, that's 16. That's greater than 10. Notice that I just picked one number that's in this range, 10, and it worked. Okay? If I picked any number that's in this range, 8 to 16, then it would work. And this is how you write the range. You write it as an inequality like this. That's all you have to do. Solve your inequalities and turn them into a range. Okay, so those are the two uses that we are going to have for the triangle inequality theorem.